Confused even and odd functions with even and odd degreed polynomials. Yes? What do you think? Who can tell me confidently? Who thinks they can tell me the difference? Well, never mind. That's an easy. I'm not going to go there because it's kind of written down. We know that even and odd degreed polynomials, number one, only applies to polynomials. And number two, mainly addresses end behavior. Even degreed polynomials have the same end behavior. They either open up or they open down. Odd degreed polynomials have opposite end behavior, either starting low, ending high, or starting high, ending low. That only applies to polynomials, and polynomials have to fall into one of those categories. Okie doke. Functions, on the other hand, general functions, and this stuff does apply to polynomials as well, but it also applies to radical functions, rational functions, log functions, exponential functions. See, with all those other types of functions, we don't talk about degree because it doesn't apply. But with these, it applies to every type of function, and you can be neither. Whereas the polynomial degrees, you have to be even or odd. You can't be neither. With even and odd functions, you can be neither. Have you guys ever heard the phrase, I before E except after C? What happened to that word? Do you know any other words that break that rule? Weird. What else? Oh yeah, either. What about niece? How do you spell niece? That's N-I-E, isn't it? Yeah. All right, there's more. I don't like when rules get broken. I'm a math person. I don't like that. Anyway, we move on. Even functions and odd functions either addresses a couple different things. Visually, we can tell based on symmetry. So if it's symmetrical to the y-axis, it's even. If it's symmetrical to the origin, now being symmetrical to the origin means that when you flip the graph upside down, it looks identical. Yes? And I wrote that below. Same graph after reflection across the x and the y-axis, or looks the same upside down. As far as algebraically having to show it, you always plug in negative x to the function and simplify it out. If you get the original function back, it's even. If you get the polar opposite, meaning a negated version of the original function back, that means it was odd. If you get some sort of combo of that, then it's neither. Okay? So, we will do these below in all ways. We'll do it algebraically first, and we'll confirm on a calculator. So, plug in negative x. Simplify it out. Now, when we square a negative x, we just get plain old x squared, and it's minus x. So, compare that to the original. If it's the same, it's even. If it's a negated version of it, it's odd. And if it's neither of those two scenarios, then it's neither. So, what do you think, Morgan? Neither. Very good. Any questions on that? Nate, if it was going to be odd, what would that have had to have looked like? What would an odd version of that look like? Very good. You'd have to negate everything. Good. So this is neither. And just visually, you don't have to do this. I'm just doing it. X squared plus x. Zoom 6. It really wants to be symmetrical to the y-axis, but it's slightly shifted left, so it's not going to work. Okay, go ahead and do 51 on your own, and then we'll reconvene. Trista, what do you think?
Even.
Even, very good. With both of these two, we can also talk about the polynomial situation because they're both polynomials. Even, right? And even again. Here's a graph of it. Just for fun. You can see the symmetry with the y-axis. On the next one, go ahead. Plug in your negative x. Olivia, what do you think? On. Very good. It's a negated version of the original. There's the visual. Same right side up as it is upside down. And this, by the way, is an odd polynomial, right? So, random question for you. We have an odd polynomial degree. It's an odd function. We have an even polynomial degree, and it's an even function. And this particular one, though, is even degreed, but neither type of function. So in these two, they're in line. These are not in line necessarily because we have the neither. Is it possible to have an even degreed polynomial that is an odd function, or vice versa, an odd degree polynomial that's an even function? See if you can come up with an example that would be the opposite degreed polynomial as it is a function. What do we think? Andrew, what do you think? An even degreed polynomial can be an odd function.
Like the first one.
Right, an even degreed polynomial. Well, this particular one's not an odd function. Can you draw a picture of something that would work for that? An even degreed polynomial that would be an odd function? I don't think it's possible. I'm not positive. I asked this question because I was just purely interested in thinking about it, and I wanted to give myself some time to think about it, and I wanted you to think about it too. I don't think it's possible. I think because if you're an even degreed polynomial, you have to have the same end behavior. So whatever that looks like, it's impossible for that to look the same right side up as it does upside down. Right? So I know an even degreed polynomial being an odd function is not possible. And I think same for the odd one. So an odd degreed polynomial has to start in one direction and end the other, which means there's no way it's going to be symmetrical to the y-axis to be an even function. Are you with me? The only thing I can think of would be like a flat line of some sort, but then that's not a polynomial function anymore. That's just like a linear y equals a number. So, all right. Good thought. 56 here is the only one that I put in front of you that's not a polynomial function, so we can't really talk about degree here, but we can still talk even and odd. So plug in your negative x. Simplify. And Bailey, what do you think? Neither. Raise your hand if you agree with Bailey that it's neither. Straight elbows so I can really feel. Oh, most of you think it's neither. Anybody disagree? Good girl. Despite being in the minority, she's going to put herself out there. What do you think?
I think it's odd because it's not a polynomial, it's a monomial. So like x cubed, it turns to negative x cubed, so it negates the whole thing.
So let me ask the rest of you if you can follow what she's saying. I'll leave the monomial, polynomial stuff out of it, not to confuse people. But if that's your function and you negate that, is that negative something that's going to get distributed here and here? No, right? And that is, you have the perfect explanation. That is because it's just a monomial. There is a polynomial within the radical portion of the monomial, but it's still one term. So you don't distribute through that. So you guys, I realize after having taught this for years now, and you guys are all fresh off of Algebra 2 when I get you, Algebra 2 really only trains you to look at even or odd with polynomials. So you guys are just really conditioned to think every sign needs to be flipped, which is not true. It is true for polynomials, and since that's all you're used to looking at, that's been okay for you so far. But in reality, when we start to look at functions other than polynomials, you've got to think about what would a negated version of that look like, and truthfully, it would just be the negation of the coefficient. Everything else stays the same. So she is correct. It is odd. Okay? Hopefully that makes sense. Those are the tricky ones to watch out for, especially when we, come up to tests and quizzes. You want to think about the stuff that's new to you. So put a little star next to that, or some sort of indicator that these are the topics that are new to you, need some more processing. You need to revisit a couple times before you really truly know it well enough for a test or quiz. Okay? Flip her over. I know that you guys did a lot of this last year, just interval notation, coming up with a domain range, and all of this. Why don't we do this? I'm just going to give you these critical points in case you can't read my graph. This one is 0, 4. This one is 1, 0. This one's 4, negative 4. This one's 7, 0. And I think that's all you need. So go ahead on your own, parts A through L, and see if you can answer those questions. Okay, before I just randomly go around the room and ask for what you have, are there any questions that we can get out in front of? Any question on any of them? Yeah.
For the range question, would you put like a bracket in -4 because it is included, or is it always parentheses around domain and range?
Who wants to take the honors and answer that question? How about for bonus points? Go ahead.
It's always parentheses.
Anybody disagree? Please disagree. Not because I don't want you to be right. Go ahead.
Isn't it brackets because like it's a point but like it's not like saying it can't be?
Correct. So let me back up. The only things that are always parentheses are increasing, decreasing, and constant. Okay? Everything else, depending on positive, negative, or domain range, it depends on whether or not it's included. And so if for -4 was an open circle, then you would use a parenthesis because it would be everything up until that -4 but not including it, and then it would come, rise above that -4 again. Since it's a closed circle, or even if it wasn't a point there and it was just a smooth line through it, you would assume that it's a closed point there, obviously. They have to really identify an open circle for it to be one. Otherwise, if it's just a smooth line, it's a bracket. Okay? So the range should be -4 to
Positive
infinity. And infinities also always have a parenthesis on them. Okie doke. Any other questions we can go out and get in front of? Yeah, go ahead.
The number at which relative minimum occurs?
Yeah, so I want to talk about both of these. In fact, next to I wrote point versus value. So there's really 3 ways you can ask. It could be phrased to ask about relative mins, maxes, and even absolute mins and maxes. On some occasions, they might say, at what point? Give me the relative maximum point, in which case you give the coordinate pair. If it says, give me the relative min or the relative max or the absolute min or the absolute max value, they're looking for the y coordinate. What is that maximum or minimum value that's being reached? And if they ask for and this albeit is definitely more rare, h, the number at which it occurs, that's talking about the x location. Does this make sense? So although they're all asking for, can you identify the relative min or max, you also have to answer the question based on the way it's being asked. So it should say relative minimum point, relative minimum value, or a location at which the relative minimum occurs. So just make sure you look out for that language. And that's something else I put a star next to because it's just slightly different, and I just want you to know to pay attention to that. Okay? So the number at which the relative minimum occurs, and this 4, -4 is our relative minimum point. The number at which it occurs is an x value of 4. So you would just say 4 or x equals 4. In I, if it says obviously the relative minimum point, we say 4 -4. If it says relative minimum value, so this would be the point, the value would be -4. Okay? Any other questions? That was a good one. Okay. Here we go. Joe, what'd you get for the domain? Negative infinity to infinity, parentheses or brackets. Good. Anybody get anything different? Yeah.
Didn't you say all the numbers?
You could, but it says use interval notation. So anytime it's it can be used, use it. But yes. X-intercepts. Julia?
1, 0, and 7, 0.
Very good. 1, 0, and 7, 0. Anybody get anything different? Good, good. Mackenzie, y-intercepts.
0, 4.
0, 4. Very good. Increasing intervals. Where it might get fun. Mitch.
4 to infinity.
Increasing from 4 to infinity, parentheses or brackets.
Parentheses and bold.
Anybody disagree or have something different? Good, that's correct. Decreasing. Nate. 0 to 4, parentheses, brackets. Anybody disagree? Good. Constant. Sarah.
Negative infinity to 0.
Oh, you're my neighbor too. Sort of. Right, Julia? She our neighbor. She qualifies. Neighborhood. So there's our connection. All right, 6 down. 10 to go. I live like a couple doors down from this one here. Negative infinity. Oh no, negative infinity to 0. All right. We are good. F of negative 3. Andrew. 4. Very good. Value of x for which f of x equals negative 2. Morgan. 2. Anybody get anything different? Good. Aiden?
They got 2 and
Right. There's just another location as well. Do you see that, Morgan? 6. Very nice. And is F even, odd, or neither? Mackenzie. Anybody get something different? Trista. Neither. This would be a neither because it's not symmetrical to the y-axis. So what's happening on the left is not a mirror image of what's happening on the right. So this is neither. Any questions? Okay. Last thing here, a step function. I don't think you've ever seen this. It's called a greatest integer function. When I show you a picture of it, you're going to see why it's called a step function. This is the symbol. Looks like a bracket, but it's almost got double panes on the two sides. Okay? And what it means is, kind of like absolute values of x has a meaning, and you guys just know at this point what to do when you're evaluating that. The greatest integer function in this notation means to simplify it to the greatest integer that's less than or equal to that number. So I have 4 examples down below. If you were doing f of 4.2, you would have to evaluate this, which, as I just said, is looking for the greatest integer less than that number, which is what? John, what do you think?
sorry, what was the question?
What's the greatest integer less than 4.2?
4.
Very good, 4. Okay? F of 5.9 would be looking for, look at that, John, it's our birthday, just so you know. 5.9, just so everyone's aware. Joe, what's the greatest integer less than 5.9? 5, very good. And that's where people get tripped up because they just want to round it to the nearest integer. It's not the nearest integer, it's the nearest integer less than or equal to that number. So what would this be? Marissa? just be 3 because it's less than or equal to. Perfect. And then this last one, f of negative 2.1, would be looking like that. And what's the greatest integer less than that number? Bridget. Negative 3, very good. Another tricky one because you want to go less than negative 2.1, which pushes you lower on the negative scale. Negative 3, nice. So just so you're aware, and I'm going to show you what this looks like. You can just watch. The greatest integer function button is under your math and under number. It's like kind of where you would find absolute value. It's called INT, and I wrote that on your notes. So you want the greatest integer function on x, let's just say, and I'm going to zoom 6, and that's what it looks like. Okay? What you don't see, though, and I'm going to freeze this and go up there and talk to you for the next couple minutes, is what happens at 1? What's the greatest integer function on 1? What's the output? Greatest integer on 1. 1, right? How about on 1.5? 1, so that's this one. So you see that. How about on 1.9? Which would be out here. What's going to happen at 2? We jump. So what does that mean for the end point of this little bar?
It's an open circle.
It's an open circle, right? So everything up to but not including 2 would go to 1. And then as soon as you get there, we jump to the next. Does that make sense? Cool. Okay. So, and that's the same for all of them. You can't see it on the calculator. You don't see open circles. But it would be a bar with an open circle on the right-hand side on all of them. Okie doke? Okay. Here's homework at the bottom. I would put an asterisk next to that before. That on your notes too, right? Because you've never seen that, have you? Or am I wrong? Have you seen that before? No.